Okay, kids, here it is. Lesson 8. Now, this is where you really have to know what you're doing because these problems get bigger and bigger. If you're not confident with your multi-digit multiplication yet, I recommend spending more time practicing with smaller problems so that you can get used to the second row partial product and holding that spot with a 0. We did have that little check-in today, and it looked like some of you guys were not quite ready yet for the quiz next week, so I want to make sure we review first before we go any further. You want to build your confidence before these numbers get big. So let me go through. I already have all the answers done, but I want to just talk you through these problems because it is so important to remember to do things in order. And there are a lot of steps, but it's just repeating it over and over and over and over. So let's just begin. And also, you have to know your math facts. You just have to know them. Print out a multiplication chart, either the ones that I put on our Google Classroom. You can print those out. I just got them off the internet. Print anything that you want off the internet if it has all the facts on it, and have that close to you when you're doing these problems. I should not be assessing your ability to multiply here. It's the way that you line things up in the standard algorithm that I am trying to teach you. So, in Lesson 8, they have added one little step here. Estimate the product first. Now, you want to estimate because when you get these huge answers after doing multi-digit multiplication, you want to make sure that you are within reason. You have an answer that has at least the same number of digits that you would have gotten in an estimate. So for example, 5 digits here, 5 digits here, 60,000, 69,000, yep, close enough. It does not have to be exact. You just want to be within 10, 20,000 of your estimated product so that you know you're on the right track. So anyway, knowing your facts. 8 times 3, 24, carry the 2. You can see I had erased all that. 8 times 1 is 8 plus 2 is 10. Carry the 1. 8 times 2 is 16 plus 1 is 17. So your first partial product is for 8 times 213. That goes here. Now, you cannot do the whole thing on one line. You have to break it up. This is the distributive property. It just looks different than the area model. Second line, second partial product. It's 2 in the tens place. That's 20 right there. That's 20. 20 times 213 is worked out on this line. You have to have a separate line for this partial product. So I know sometimes you guys will forget, but this 0 needs to hold this place so that this digit will be placed in the tens column. It's very important. In fact, it's critical. If you don't put this here, if you put it over here, you're going to get the whole rest of the problem wrong, and I don't want that. I want you guys to understand, yes, put a 0 here. Yes, move it over. We're multiplying with 2 tens, so proceed in the tens column. 2 times 3 is 6, or 20 times 3 is 60. 2 times 1 is 2. That's going to go out to the left because we're in the hundreds place. Then 2 times 2 is 4, and again, that's 2 tens times 2 hundreds is 4 thousands. So everything should work out into the proper place value positions. Next line, it's 300 times 213. So we're taking each digit and multiplying it by 213. So in this final row here, we have the 0 from the ones place, the 0 from the tens place, and then you get over to the hundreds place. 3 times 3 is 9, but it's really 300 times 3, so it's 900. That makes sense. 3 times 1 is 3, 3 times 2 is 6. Line these up and add, and you get your final answer, 69,864. So very, very important. Don't go on if you don't understand why you need these 3 lines. This line here is for the 8. This line here is for the 2. This line here is for the 3. Okay? Now I'm going to go a little bit faster because we don't want to spend 5 minutes per problem. First of all, estimate. 662, round it up, about 700. Round this up, about 400. 7 times 4 is 28. Count your zeros. It's an overestimate, by the way. Then we go ahead and move to the standard algorithm. 3 digits, 3 partial products. 2 times 2 is 4, 2 times 6 is 12, carry the 1, 2 times 6 is 12, plus 1 is 13. Notice that when I get up here to the top, I'm always adding what's on the top. Don't forget that step. It's very important. If you don't add, you'll get the digits wrong and it'll mess up your final answer. Second partial product is the 7 times 662. So I have to hold this place with a 0. The first place needs to be held with a 0. Then you multiply. 7 times 2 is 14, carry the 1. 7 times 6 is 42, plus 1 is 43. 3 goes down and the 4 goes up. As you can see, I've already done the work, so the 4 was back here. 7 times 6 is 42, plus 4 is 46. So this partial product now is out here in the 10,000s place, but that makes sense because I was multiplying 662 times 70. Now this 0 is for the 1s, I'm done with that, and this 0 is for the 10s, I'm done with that too. I'm over here in the hundreds place. When you start multiplying with this digit, your first answer will go here in the hundreds place. 0, 0, next. 3 times 2 is 6, 3 times 6 is 18, carry the 1, that's what that was. 3 times 6 is 18, plus 1 is 19. Add, 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 and that's your final answer. Compare to the estimate, and I should be within reason, and they both have 6 digits, and I'm in the 200,000, so I am just fine. Let's cover that up, save it for later. All right, so this one, instead of going up, rounding up, we rounded down, 739 down to 700, and 442 down to 400. So since we went way down here and way down here, that's why I have this gross underestimate. 7 times 4 is 28, and 1, 2, 3, 4 zeros. So we went down 39 and down 42. That's what I'm talking about here, but standard algorithm. Know your facts. 9 times 2 is 18, carry the 1. 2 times 3 is 6, plus 1 is 7. 2 times 7 is 14. So there was nothing else to add up here because those are from the later numbers. Done with this, hold that spot with the 0. Move to the 4 tens and start multiplying here. 4 times 9 is 36, carry the 3. 12, 13, 14, 15, carry the 1. 4 times 7 is 28, plus 1 is 29. Second partial product. Notice that all of these start stacking up the zeros. Second row has 1 0, third row has 2 zeros. So far, it's been a pattern that you can predict. Third partial product. Now I want you to look carefully. If I just multiplied everything by 4, I'm going to get the same answers. Notice it's 29560. 29560. So when you get really good and you start noticing things like that, it can save you a little bit of time. But you could go through and multiply it all again if you wanted to. And then you add up and you should end up with 326,638. And you compare that to your gross underestimate, and yes, this is more, but that's okay. Next one. Round this to 800, round this to 500. Don't forget, if you have a 0, be careful with your additional zeros. So 8 times 5 is 40, and then 1, 2, 3, 4 zeros. 1, 2, 3, 4. Standard algorithm. Notice that this one has a 0 in the middle of the lower factor. Now, why did I choose to put this one on the bottom? Because I don't want to have an extra row of partial products. So we talked about that in lesson 7, how that's a good strategy to save yourself time and energy. 7 times 1 is 7, 7 times 9 is 63, 3 down, 6 up. 7 times 4 is 28, plus 6 is 34. Now, row 2, 0 for the ones. This 0 here is held right here by this one. Okay? Then you move over to the hundreds place and start writing your next answer right in the hundreds place here. 8 times 1 is 8. 8 times 9 is 72. 2 down, 7 up. 7 up, haha. 8 times 4 is 32, plus 7, 39. And you should have 392,800. Don't forget the zeros. 396,237 compared to this. Yes, it's within reason. Next one. Estimate about 4,000. About, if this one goes up, look at that. I went up 500, so I went down 50. I'm just trying to get something that's a reasonable estimate, so it doesn't have to be exact. 4 times 6 is 24. 1, 2, 3, 4, 5 zeros. Set up your standard algorithm. 6 times 2 is 12. Carry the 1. When I have a 0 up here, my answer is going to be with whatever that digit was. So 6 times 0 is 0, plus 1. There it is, 12. 6 times 5 is 30. 0 down, 3 up. 6 times 3 is 18, plus 3, 21. Watch out. This is for the ones place. Now, 5 times 2 is 10. This is the first partial product here. Carry the 1. That just comes right down, 10. 5 times 5 is 25. Carry the 2. 15 plus 2 is 17. 17510, 0. Third digit in my problem. This is the ones place. This is the tens place. Now I'm in the hundreds place. 6 times 2 is 12. Carry the 1. Oh, it comes right down. 6 times 5 is 30. The 0 goes down. The 3 goes up. 18, 19, 20, 21. Okay? So add up, and you get your final answer, 2,297,000, and 2,400,000 is close enough. Round up, round down. Okay, so when but this is only going down by 40, 41, and this is going up, and this has we're going up several hundred here, so anyway, we end up with a gross underestimate. And if you do the 700, look, I have another estimate here. If I go up to 800, then this is actually a great estimate because it's very close. So just kind of realize that when you're estimating, not everyone is going to have the same estimate. 4,390 times 741. 1 times 0, 0. So this just happens to be a 0 because that's the product for 1 times 0. That's not any special place. It's just the answer. 1 times 9 is 9. 1 times 3 is 3. 1 times 4 is 4. Next line, this is to cover the 1. Go to the tens place. 4 times 0, 0. Okay, the first one's always going to be a 0 because that's what's here. 4 times 9, 36. 6 goes down, 3 goes up. 4 times 3 is 12, plus 3, 15. 5 goes down, 1 goes up. That's 16, plus 1 is 17. So 17, 5, 6, 0, 0. Third row. Got a 1, got a 4, got a 7. This is for the 1, this is for the 40, this is for the 700. Got the ones place, got the tens place, and of course here is our first 0. 7 times 0, 0. 7 times 9, 63. 3 goes down, 6 goes up. 7 times 3, 21, plus 6, 27. 7 goes down, 2 goes up. 7 times 4 is 28, plus 2 is 30. All lined up neatly. Add, estimate, compare. It's good. It's good. Next, need to move my book. Intermission. Do, 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 do. Now it's going to focus because I said focus. Ha! Look at that. Somebody's listening. 530 rounded down to 500, then round down to 2,000. You have your estimate, set it up. When I have a 0 first, I'm just going to put that 0 right here and move straight to the tens. done with that. I don't want to have a row of zeros. Why? That would take up time and space and lead and energy and thought. 3 times 5 is 15. 5 goes down, 1 goes up. This is 21 plus 1 is 22. Carry the 2. That goes here. Boy, I hope that's right. Let me go back. See, I lose my place so easily. 21, 22. Oh, I feel like that's not right. But I think I checked that before. Okay. Let's go with this. I'm going to do it on a piece of paper so I don't mess it up. 5, 30, 0, 15, 22. That should be a 2, and then that should be a 6. Why? Why is this like this? Why are you the way that you are? Let's just do this one together. All right. Love that. Okay, so be careful with the zeros. Don't even think twice about it. Like, it still throws me off. So we have a 0. We're starting here. Go to the tens place. 3 tens. This is essentially the row for 30 times 2,075. So 3 times 5 is 15. Carry the 1. 3 times 7 is 21. Plus 1 is 22. Here's the 2, but we have to carry the 2 over here. 3 times 0 is 0, but that's when that 2 falls down, so I don't know what I was doing before. And 3 times 2 is 6, and we had nothing carried over. Then, okay, now watch this. I have 0 for the ones place because I'm done, and 0 for the tens place because I'm done. And now I'm on to the hundreds place. So this is 5 in the hundreds place. It's really 500 times 2,075. 5 times 5 is 25. Now I have 2 there. 5 times 7 is 35 plus 2 is 37. There's my 3. 5 times 0 is 0, but I need the 3 to come down. And 5 times 2 is 10. So I don't know what I did before, but nobody caught it in several years. Can you imagine? Everybody was tired at that point. And then add and add and add and add, and then you should end up with your 1,099,750, which is a lot closer to the 1 million of our estimate. So that would be your final answer. All right, next one. Good thing we fixed it so I didn't have to do another video. Whew, nobody has time for that. Okay, 4,000 rounded, then 603 rounded to 600. Multiply, get your estimate, set it up. 3 times 4 is 12. That's the 1 because 3 times 0 is 0 plus 1. Then 3 times 0 is 0. Hold that place. 3 times 4 is 12. This is for the ones place. This is for the tens place. This is now the hundreds, and it's right in the hundreds column. 6 times 4 is 24. 4 goes down, 2 goes up, but 6 times 0 is 0, so the 2 ends up right next to it. Then 6 times 0 is 0. 6 times 4 is 24. Add all your digits and you end up with 2,414,412, which is really close to your estimate. And on to the last one for the front page. Round up, 1,000. Round down, 3,000. Close enough, 3 million. 7 times 5, 35. Look, there's a 0. The 3 falls down. 7 times 1 is 7. 7 times 3 is 21. Next row, I have 3 partial products because I have 3 digits. 8 times 5 is 40. Oh, sorry, this is the ones place. This is now our 40. This is the 0. The 4 went up, and then it falls down. 8 times 1 is 8. 8 times 3 is 24. This is the ones place. Hold that. This is the tens place. So you've got to bump your next partial product over. 9 times 5 is 45. The 5 goes down, the 4 goes up, but it just falls right down. 9 times 1 is 9. 9 times 3 is 27. And then you add up and you have your final answer compared to your estimate, and it's lovely. Turn the page. That was so much work, but we're almost done. Well, sort of, but not really. Okay, word problems. So on the next one, each container holds, here's the tricky part. 1 liter and 275 milliliters of water. That turns out to be 1.275. Okay, so because of the 1, 2, 3 places, we talk about King Henry died unexpectedly drinking chocolate milk. And so we have the deciliters, the centiliters, the milliliters place. So we have 3 places or positions to the right. Milliliters ends here. 1.275. It works out great. The metric system is really easy. Each container holds this much water. How much water is in 609 identical containers? Find the difference between your estimated product and precise. So you can round this to 1,000, round this to 600, and you think, okay, well, I should have around 1 liter times 600 would be 600. And we'll get to that next. And then the 1.275 times 609, notice that sometimes I just have this blank. Why? Because it would be a 0. And some kids were saying, oh, I don't want to put a 0 there. It makes it messy. Well, if you want to move it over too, that's fine. I'll show you why. That's okay. So this is the 9 times 5, 45. And then 63 plus 4, 67. Carry the 6. 18 plus 6. 24. Sorry. Brain fart. 9 times 1 is 9 plus... Good heavens. Is 9. Plus 2 is 11. Oh, it's a slow day. It must be Friday at 5:50 p.m. Yes, and I am ready to go home. So anyway, why do I have nothing here? Because this is for the ones place, this is for the tens, and now I'm in the hundreds place. So 6 times 5 is 30. The 0 goes here, the 3 goes up, 42, 43, 44, 45. 4 goes up, 12 plus 4 is 16. Carry the 1, 6 plus 1 is 6 plus... 6 times 1 is 6 plus 1 is 7. So these digits are all in the right places, and I don't have to have anything there. If you want to put a 0 there, because I've been telling you to all the while, you may, and you can like put a little gray in them too. I just want you to know that this is okay. Then you take this actual product and you subtract your estimated amount, and then you have your difference. This one is about a club having some money to purchase new chairs. After buying 355 chairs at $199 each. Come on, just round up. It's going to be over $200 with tax. There was $1,068 remaining. How much money did the club have at first? So these are kind of fun because it's really like you don't know what you're starting with. So what we do know is that they spent some money on chairs. 355 chairs at $199 each. So when you calculate this, you get your $70,645 spent on chairs, which is this much that's going to come off of our unknown number. Then there was money left. So if you take this and you put on what was left, then you can see what they had at first. So it's kind of like a working backwards. You work with what you know and a little bit more of what you know to get back up to what you started with. I hope that makes sense, and we can talk about it more in class. And then finally, the last one. So far, Camilla has collected 14 boxes of baseball cards. There are 315 cards in each box. Carmela estimates that she has about 3,000 cards, so she buys 6 albums that hold 500 cards each. Will the albums have enough space for all of her cards? Why or why not? Well, if you have your 315 cards in each box, then you have to figure out how many she could fit into the albums. And if you end up with the 3,000, then she will not have enough space because she underestimated. So when you look at what she's doing, she estimates that she has about 3,000. And so anyway, she ends up with an underestimate and she will not have enough. For B, how many cards does she have? So you can figure it out right here. Step 2, 315 times 14. Carmela has 4,410 cards, but she, rounded down, rounded down, and she really should have gone up so that she could have a better estimate. And how many albums will she actually need? So you find the difference, and then you can divide that by the 500, which is how many cards can fit in each album. And so if you get this left over, the 1,410 divided by 500, and you get 410 cards left over, you don't want to have the cards left over. You want to put all the cards in the album. That's the idea, is if you're going to collect the cards, they have a place to go. So you bump this up, you put this amount into the +1, and so she needs 3 more albums so that she would be able to fit all her cards in. Heavens to Murgatroyd. That's a long one. See you soon.